Section 1.2, Part 1 video. In this section, we're going to look at some application uses of what we just looked at, which was linear equations. How they're actually used in a particular problem that applies to us in everyday life. We often refer to these as reading problems. Now, before you panic on reading problems, listen to the video in complete detail. Give me a shot at explaining it, and really try to work these following some of the things that I want to talk to you about. So let me give you some suggestions first on application problems in general. All right, because a lot of times when students, first thing they do when they see a reading problem or application problem is their mentality is, well, I can't work it, hadn't been able to work it, not going to work it, so I'm just going to miss this problem. So try to get out of that mentality, give me a shot at it, and really work at it. And if nothing else, just try to get a little better than what you were at the beginning on it. And I think I can help you if you'll really give this a shot. All right. Whenever we solve a reading problem, the first thing that I want you to do whenever you read a reading problem is I want you to just read the reading problem through and just get a general idea of what's happening. Just get an overall picture. Now, in this section, we're only going to be dealing with two kinds of application problems. Perimeter problems, you'll hear that in 3 or 4 of your homework problems, perimeter. And then the next one will be what's called investment problems. We're going to handle both of those separately. But before we do that, let me talk to you in general about reading problems. How to approach a reading problem. Because see, later on in the course, we're going to be dealing with some reading problems that's a little bit more difficult. So you need to have an approach to a reading problem. I'll say this now and I'll say it again in just a few minutes. Whenever I grade a reading problem on your exam, there will be 4 components that I look for in every reading problem. And I will show you these as I work through these myself. Number 1 will be what's called your heading. You'll see what that is in just a second. Number 2, your equation. Number 3, where you solve it. And then number 4, a concluding statement. Those are the 4 components that I will ask you to show on every reading problem. So let's talk about your heading first. Here's what your heading is. Whenever you're solving a reading problem by algebra, the first thing we do is we do what's called declaring the variable. And what that means is this. When I do my heading, the first thing I'll write when I'm writing my heading is I'll say, let X be blah, 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 blah. Now, how do I know what I want X to represent? A lot of times that's pretty easy. Here's what I mean by that. When you read your reading problem, if you are asked one question and one question only, that's what we let X be. So, for instance, if it says, find John's age, the first thing I would write on that problem is let X be John's age. What is Tom's age? Let X be Tom's age. What's the speed of the boat? Let X be the speed of the boat. How long is the shortest side? Let X be the length of the shortest side. So if you're asked one question, you let X be that. Now, sometimes you're asked 2 questions. I'm going to summarize this for you in just a second and let you write it down. If you're asked 2 questions, you can't let X be 2 different things. For instance, let's suppose it said this, find John and Tom's age. You can't say let X be John and Tom's age. Why? Because if I say let X be John and Tom's age, and I get X to be 20, what am I assuming? I'm assuming they're the same age. So you can never let X be 2 different things unless you're told in the problem that they're the same. So if it said John and Tom are the same age, then I could let X be John and Tom's age. Let X be John's age, let X be Tom's age, because I know they're the same age. But you can never let X be two different things unless you know that they're equal, and in which most cases they are not. So, if I'm asked two questions then, how do I know which one to let X be? In that case, if you're asked two questions, let X be the one you know the least about. In other words, if it gives you some information about one and that doesn't give you some information about the other, let X be that. Let me give you an example. Suppose I was looking for John and Tom's age, and suppose I said John is 5 years younger than Tom. John is 5 years younger than Tom. Now, do we know how old either one of them are? No. But we know that John is 5 years younger. So we know a little something about John. We don't know anything about Tom's age, but we know John's 5 years younger. So here's what we would do. Since we know nothing about Tom's age, we would say, let X be Tom's age. Now, how's that going to help? Because if John is 5 years younger, then John would be X what? Minus 5. Now, what if it said John is 5 years older than Tom? It'd be X and then X what? Plus 5. So that's if you know more about one than you do the other. Now, if you don't know more about one than you do the other, in that case, you could let X be either one. We'll talk about every bit of this in detail. So if you want to write this down right quick before we start our problems, write this down. When declaring the variable, use the following. Now, there's going to be three things here. Number one, if only one question is asked, let X be that question. Number two, if more than one question is asked, let X be the one you know the least about. And then number three, if no information is known about either, let X be either one. Let X be either one. So, if I've got one question, I'm going to let X be that. If I've got two questions, I'm going to let X be the one that I know nothing about. If I've got two or more questions and I don't know anything about any of them, then I'm just going to pick one of them and let X be one of them. And I'll show you what to do after that. All right. So, we're about to do a couple of problems here. And let's see. Yes, we're going to do two problems here. And these two problems that I want to do with you are perimeter problems. Now, before I do these two problems, let me make sure you understand or you know what the word perimeter means. The perimeter of an object is just the total distance around it. So like, if I was talking about what's the perimeter of this building, I'd take a tape measure, go all the way around this building and measure it. Now, if you're talking about an actual polygon shape, like a triangle or a rectangle, the perimeter is the total distance around it. So if you're talking about a triangle in geometry, the perimeter would be add the three sides together. The key word there is add. If you're talking about a square or a rectangle, add all four sides together. If you're talking about a pentagon, five-sided polygon, you add all five sides together. If you're talking about a circle, the perimeter is what we call the circumference of it. It's how far it is all the way around it. All right, so before I give you this problem, let me say one more time right quick. Start with your heading. That means what you're going to write down what let X be. Then your equation. then solve it, then concluding statement. All right, here's our first problem. Write this problem down. This is our first example. All right, let me just say, let me look. Okay, yeah. The width of a rectangle is 54 centimeters. Find its length if the perimeter is 218 centimeters. Now remember, when you're copying that, you can pause that to make sure you get that down. Okay, so here's what we're going to do. Our first example. I'm a visual person, so we're talking about a rectangle. So it may or may not help you if you draw a rectangle. Now remember, in geometry about a rectangle, one of the features about a rectangle is opposite sides are equal in length, if you know it's a rectangle. All right, what is the first thing I will be grading? Your heading. Your heading will look like this. Your heading. Let X be. Now, what are we looking for? It says the width is 54 centimeters. What is the length of the rectangle? So let's write it out. Let X be the length of the rectangle. And I would suggest that you write that out in a full thought. Just don't say, let X length. Write out the whole thing. Let X be the length of your rectangle. All right. I just got some points right there by doing that. So that's the first thing I'm looking for. Now, the next thing I'm looking for is your equation. Now, your equation in this problem, we're talking about perimeter. What do we know about perimeter? What is perimeter? It's the total distance around your object. Now, what object do I have in this problem? I have a rectangle. So that means a rectangle has 4 sides. So if you add the 4 sides together, you get what the perimeter is. Now, do we know what the perimeter is? Yes, we do. The perimeter is 218. Now, do we know the 4 sides? Yes, we do. How wide is it? Its width was 54. So that's 54. But there's another one, because there's one on one side, one on the opposite side. So it's 54 on one side, 54 on the other. Now, do we know that's how wide it is? Do we know how long it is? You say, no, we don't. Yes, we do. We said let what? X be how long it is. Now, I don't know what X is, but I do know how long it is. It's X. You say, what is X? It's X. So its length is X and X. So this is X and that's X. So that will be X and that will be X. Now, if you look at this problem, that's your equation right there. That's the second thing I'm looking for. Now, if you'll look at this problem, that's just like what we finished in the last section. So X plus X is 2X plus 108 equals 218. Subtract 108 from both sides to get 2X equals to 110. Then X equals to 55 if you divide both sides by 2. All right, what would I say I'm looking for? Number 1, the heading. There it is right there. Number 2, your equation. Number 3 is where you solve it. Now number 4. The fourth thing I'm looking for is write out a concluding statement. Now, what were we looking for? The length. Now remember, what was the length? X. Have we found what X is? Yes, 55. So the length is 55, and make sure you put units on your answer. 55 centimeters. Now, how do I know that it's centimeters? Because the perimeter was 218 what? Centimeters. Now, is there any way that we could check this? Yes. If I did 55 plus 55 plus 54 plus 54, if I added those together, I would get 218 centimeters, which is the perimeter. Now, I'm well aware, be sure you listen to me here on this. I'm well aware that some of you in here could have solved this equation without setting this up. When I graded, I am looking for the heading, the equation, the solving, and the concluding statement. If you give me just an answer, I don't care if the answer is right or not. If you give me just an answer without the work, you will receive no credit. And I know that sounds harsh, but here's why. Later on, we're going to be dealing with some reading problems that's more involved. And I want you to learn how to set up the reading problems even in the easier cases. So I want the work in order for you to receive credit. So make sure you remember that. So practice working on the setup of these problems. Okay, let's do one more perimeter problem, and that will close out this video. So write this problem right here down. Here's the problem. A triangle has a perimeter of 80 feet. The second side is 4 feet longer than the first side. The third side is 4 feet less than twice the first side. Find the lengths of the three sides. Okay, so what makes this problem different? Well, first of all, it's a triangle. And so I've got a triangle. It doesn't matter what you draw your triangle to look like. I got three sides. And so what we're doing now is we're going to add in these three sides together, and it's going to be equal to 80 feet. Now, what do I put on these three? Well, you said, well, we got to put an X and an X and an X. We can only do that if it says all three sides are equal. So, for instance, if it said two of the sides are equal, I could put an X and an X. But did it say any of the sides are equal? No. As a matter of fact, none of them are equal. All right, what am I looking for when I grade the problem? Heading. All right, so the first thing I'm going to write is let X be the length of, now let me stop right there. Okay, what did it say? Let's go back and read. You got three sides. Does it talk about any of the three sides? Yes, it does. It says the second side is 4 feet longer than the first side. So it tells me something about the second side. Does it tell me anything about the third side? Yes. It said the third side is 4 feet less or shorter than twice the first side. So it tells me something about side 2, tells me something about side 3. But does it tell me anything about side 1? No. When more than one question is asked, you let x be the one you know the least about. So I'm going to let x be the length of the first side. Let x. Now, if x is the length of the first side, what did it say about the length of the second side? How much longer was it? 4 feet longer. Now, what does 4 feet longer mean? It means you add 4. Like if I said I have $4 more than you do, and you have 10, I have 10 plus 4, which is 14. So if the second side is 4 feet longer than this one, it's x plus 4. Now, what did it say about the length of the third side? It said the third side is 4 feet shorter. Well, if 4 feet longer means add 4, what does 4 feet shorter mean? Or less? Subtract 4. Now, did it say 4 feet less than the first side? No. It said 4 feet less than twice the first side. Twice the first side. 2 times that. You say, well, wow, we have 3 headings in this problem. Yes, we do. Why do we have 3 headings? Because we're looking for 3 questions. Very important what I'm about to tell you right here. The number of headings you have should always be equal to the number of questions or things you're looking for. See, in the first problem, what were we looking for? Just the length. So we had 1 heading. In this problem, we're looking for the lengths of the 3 sides. So we're looking for 3 things, so we have 3 headings. Now, why did I let x be the first side? Because it said nothing about it. It said the second side is 4 feet more than this one. That's x plus 4, not 4x. And then it said the third side is 4 feet less than twice the first side. The word twice means 2 times. And that needs to be 2x minus 4, not 4 minus 2x. All right, there's my heading. 3 headings. Now your equation. If you add these 3 sides together, it equals to, there's the first side, there's the second side, there's the third side. And we're adding these together. Okay? Add the x's together. X plus x is 2x. 2x plus 2x is 4x. The plus 4 and the minus 4 adds out to 0. Equals 80. Divide by 4 to get x equal 20. Alright, so the first thing I'm looking for is your heading. The second thing I'm looking for is the equation. The third thing I'm looking for is where you solve it. Now the fourth thing. The fourth thing is where you write your concluding statement. Okay, what's my concluding statement? Let me give you a suggestion here. When you get to the last part, after you solve it, always look back up at your heading. Now, how many headings did we have? 3. What was the first heading? Let x, 20, be the first side. So the first side is the 20 feet. Now, look back up at your heading. What did it say about the second side? X plus 4. So 20 plus 4 is what? 24 feet. Now look back up at your heading. The third side. 2 times 20, which is 40. 40 minus 4, which is 36 feet. For the third side. And if you add these 3 together, you wanted to double check it, you see that you get 80 feet. So when you get to the last step, the last part where you write out your answer, your concluding statement, always use your headings to write out your concluding statements. And the number of headings you have will always be equal to the number of questions that you're looking for in the problem. So that concludes the perimeter problems in section 1.2. We will now, in the next video, do the other application problems.